Thank you very much for the introduction and for inviting me to this online event. I'm happy to share our experience on, let's say, how we are managing various cultural heritage objects in Slovenia. In Slovenia, we have to be aware that, let's say, quite some of our cultural heritage is partly or entirely made of wood. So that's why, addressing the wood in the cultural heritage is becoming more and more important, especially right now. On the other hand, what I'll talk about today about one castle. That castle is, that's where, because I'm aware that you're not very familiar with the geography of Slovenia. To be honest, I've first heard of this castle Leskovec when they asked us to do the inspection, because the castle was very abandoned and it was not that famous at this area. This castle locates somewhere between Ljubljana and Zagreb, in the area with very strong agriculture and wine production. That's how the castle looks like when I visited it. When we talk about the castles in Slovenia, we have to be aware of one thing. There was, after let's say the last period of the Second World War, a lot of castles in Slovenia were destroyed and burned. And after the Second World War, as you probably know, there was, at that time, it was the majority of the castle owners were expelled from Slovenia, at that time Yugoslavia, and the castles was mainly used for, let's say, as kind of seats of the institution for the privileged people, because originally the idea was okay to put people in the castles, but living in the castles, if they're not properly maintained, it's nightmare, let's say that way. And that's how the castle looks like. When we first visited it, the majority of the inspection was performed last December and this January. So the majority of the work, what we are running. This castle, the renovation is going on right now for, let's say, a few years. And it's very likely that the renovation will go on for additional few years. That's how, the castle is in a rather bad shape right now, but the local community have a lot of plans to make this castle as a location for the cultural events, for the wedding, wine tasting facilities, maybe some boutique, small hotels, or things like that. But in order to do that, the castle needs to be maintained, because right now it's not suitable, not even for a prison. That's how the castle looks like from the top. It has 4 towers, the central yard, and this castle was first mentioned in 15th century. The Slovenian polyhistor Valvasor make a drawing of this castle, let's say, in the 16th century. That's how it looked like at that time. That's also, we have to consider that the images might not be very accurate for this time, but the original idea is very similar to what we see today. In the 16th century, it was renovated. In 1945, it was nationalized. And then it was abandoned after 1995 for almost 30 years. And those years, as long as when this castle was abandoned, in these years, this castle suffered a lot. Within this castle, we see a poster of Kevin Costner. That's an image on the left side of how the Kevin Costner looked at the time when this castle was in use, and that's how it looks today. We see the difference with Kevin Costner, and see the difference on how the castle looks like. The majority of the wood in this castle is in the roofing. That's how the roofing looks like. And the question that we got is this roofing construction in good state, or we need to replace it? And if the material is degraded, how is it possible to reinforce it? Is it possible to use wood preservatives to stop decay? And how to proceed? They want to have kind of recipes. And that's why, I mean, we have been in this castle for, let's say, 7-8 times to assess every beam in this castle and to recommend, let's say, what to do in the future. I mean, that's how the construction looks like. I mean, part of the material was already replaced. I mean, for example, predominantly of the roofing material. The rest of it is just there, let's say that way.
Professor Humar, I'm so sorry to interrupt. May I just translate some main ideas?
Okay.
Thank you. Отже, колеги, йдеться про те, що ось, власне, ви бачили історію цього замку, який знаходиться в Словенії, замок Лесковець, і група, команда Словенського університету, вона займалася завданням дослідити стан деревини в цьому замку. Ви бачили попередні фото, так, і поставилось питання, що робити далі? Отже, від того дослідження, від аналізу цієї групи, наукової оцінки стану деревини буде залежати його доля. Що робити? Чи повністю змінювати, збирати, чи щось далі продовжувати зберігати? Ось це такий моніторинг. Thank you very much. Please continue.
Okay. I mean, on part of the castle, we can see there was already damage. You can see the beams that were deteriorated from the roofing. So part of the castle was already like kind of rather dangerous to walk on this castle at the very moment. I mean, like this one. I mean, we can really see that the part was demolished already. We have to consider that the castle was empty for 30 years. There was zero maintenance during those 30 years, and there was a lot of leakage. There were a lot of problems noticed within this castle. I mean, and for example, there were some examples of the bad maintenance. For example, for some of the beams, we were not sure why certain things happened. For example, the owners, I don't know in which period, decided to cut this beam on this point. I will show you. You can see that they decided to cut the beam on this point. I mean, they simply cut it with a saw, and the way the beam was loaded, I mean, it was under the bending load pressure. There was a huge I mean, the tension was released, so the force goes on both directions, and there was a huge crack developed. I mean, this influenced the static performance of the castles, of the whole floor. I mean, so there was a lot of that kind of examples where people, I don't know, whether they were looking for some fuel wood, or they want to have more space and they want to remove part of the wood. We have no idea why this happened. And I mean, during our study, we have to recommend what to do with this kind of the material. And we recommend them that, I mean, they should apply the screws, and they should fix all those two beams together. I mean, they should apply force to apply adhesives in those cracks and integrate this member, I mean, to fill those forms with adhesives and this will enable the beam, let's say, to be in service, let's say, in the future. In addition to that, I mean, they also recommend them to apply some carbon fiber on the side, what will help, let's say, to maintain the structural integrity of this beam. I mean, for example, on the other case, there was this kind of the maintenance. I mean, they use polyurethane foam to fix the roofing in one of the buildings. There was probably some flecking, I don't know what happened over the top, and they used this kind of technology to repair it. There was a lot of repairs like this. I mean, and this kind of repairs, they didn't contribute to the good performance of the castle. So, I mean, so we came to this kind of building and want to assess the condition. I mean, and the decay of wood is primarily associated in our climate conditions with the wood decay fungi. Wood decay fungi are the prime object of the decay. And that was true in this castle as well. In addition to that, I mean, insects are the second most important factor. I mean, but insects are more important, let's say, in Slovenia. Are less important in Slovenia than in some of the let's say, more tropical or warm countries. I mean, when we're talking about the wood, I mean, decay fungi, we are aware that there are 4 types of fungi that appear in the buildings: brown rot, white rot, blue stain, and substain. Within this cluster, we primarily notice brown rot fungi. I will show there some examples. Those brown rot fungi are the fungi that predominantly degrade cellulose, and what remains is the oxidized lignin. And in addition to that, there were some substain fungi. Substain fungi are the fungi that actually not degrading the material, but they're living out of the residues. We can find them also on the plaster. We can find them on the walls, and they're usually associated with condensating water. If substain fungi are present, we are aware that there are leakage problems. And
One moment, if I may. Отже, колеги, йдеться про те, йдеться про те, яким чином зберігати, яким чином, власне, розв'язувати ті проблеми, які виникли, тому що 30 років фактично замок, ніхто не піклувався замком, і він стояв і врешті-решт прийшов цю стадію, яка потребує втручання. І вам показують різні можливості, різні технології, так, як скріплювати. В першому випадку це скріплювали дерево, ну а загалом там є різні технології, які дозволяють, власне, з цим деревом щось робити, так? І, власне, оцей wood decay, що у вас є зараз, це є розпад дерева, так? От, синергія, фунджі і синергія. І зараз ми почуємо, які ще є, там є приклади, так? Що роблять з червоним деревом, що роблять з іншими породами дерева, тому що там є різні технології, коли маємо справу з деревом. Thank you very much.
Okay. But in the nature, it's like that. None of these organisms acting alone. I mean, all those organisms are always acting in synergy. I mean, if they're acting in synergy, I mean that this means that, I mean, their action is not, the result of their action is not 1 + 1 = 2, but it's more than 2. I mean, so the damage is then even facilitated because of this damage. I mean, I would just like to show one of the examples how those factors work on one of the wooden cabin in Slovenian hills. Those photos, the first one was taken in 2004. I mean, at this time, this building was already almost abandoned. I mean, there were some damages. But later on, we can see that, I mean, it was from year to year, we have more damage until everything collapsed. I mean, in 10 years, this building, for 2004, 2015, the building completely collapsed. I mean, if we're not maintaining the building, everything can move really, really fast. I mean, and then, I mean, we have this building, let's say, in this kind of condition, let's say, years ago. We're always joking that those buildings are waiting for the 1st of May, because on the 1st of May, we're always burning the open bonfires, and we should burn this wood, let's say, in the bonfire. And I mean, whenever we are talking about the wood decay fungi, I mean, we are aware that we cannot stop the decay. We can only slow it down. And if we want to slow it down, we have to keep wood outside the optimal degradation conditions. I mean, and this means that the easiest way how to do it is to control the wood moisture content. I mean, and if we're controlling, I mean, this means that wood have to be drier than this. I mean, so this means that woods have to be drier than 25. Usually the limit that we state is the maximum limit is 25, but we recommend the moisture content of 20. 20% is the moisture content that we ask, because we cannot fully control the temperature, because the temperature is outside condition, but we can control the moisture content. That's why we always ask all of those house owners that they ensure with the maintenance that moisture contents never exceeds 20%. Mm-hmm. But the things are a bit more complicated, because for some of the wood species, sometimes the moisture content limits are even lower. The lowest moisture content reported is 14.6. That's the minimal moisture content of wood where the decay happens. This means that it's very low. I mean, usually the moisture content of the wood in the building, let's say in the residential building is around 13-14%. So this one is almost on that limit. But we have to be aware that this is true for beach, and there is always water source nearby. I mean, like water source means soil or some wet pockets. I mean, but in general, we talk about 20%.
Excuse me, may I translate a bit? Отже, колеги, йдеться про, мені здається, що хтось там проситься ще, чи ні вже? Йдеться про збереження дерева і контроль за вологістю і за станом, чи воно сухе, чи вологе. І ось там ви бачили таку табличку, бо ще був той будиночок, так, який розпадався. То, власне, професор пояснював, що з часом стає все гірший і гірший стан, тому треба зберігати його якнайшвидше. І показував табличку, власне, вимірювання різних таких показників, які треба контролювати для того, щоб зберігати дерево в належному стані. Thank you very much.
So the first things that we do on the building, it's not really in this consequential order, but we usually isolate some specimens for laboratory analysis. And the first things what we do, we determine the wood species that was used for the production of this castor in this example. And in addition to that, we try to also estimate some pests present. For this kind of assessment, we're usually using the digital microscopy because it's very simple. There's no need for a lot of sample preparation. And based on our analysis, we noticed that the majority of the construction within this castle was made of oak and Norway spruce. I mean, we have to be aware that in the region where this castle is located, there are quite many naturally oak forests. So the castles were made of oak. So it's logical, but it probably in between, because oak was still very expensive material, but we believe that in some later maintenance work or some additional work was also, let's say, for some less exposed material, was also made of the Norway spruce. And when we're talking about oak, especially in Slovenia, this is the region where I have to mention that in Slovenia, let's say up to the 1850s, there was a law that oak was allowed to be used only for noble families, church, and military purposes. So oak in this area was in the time when the castle was built was very expensive material. So I mean, if they use oak for this kind of construction, this indicates that the owners of these castles at that time were rather important.
One moment, I'm sorry. Отже, йдеться про використання дуба і ялини, власне, з метою будівництва в замках. І йшлося про те, що в давнину дуб вважався настільки дорогим матеріалом, що його дозволяли використовувати тільки при будівництві ось таких палаців, церков і для якоїсь мілітарної причини, так. А решта не дозволялось, бо він був дуже дорогий, дуже берегливий. Thank you.
Sure. I mean, the basic properties of the material is indicated here. Oak is very durable material, spruce is less durable. The density of the oak is higher than of the oak, and also the mechanical properties of the oak are better compared to the spruce. I mean, and that's why that's indicated because it's obvious that because there was a lot of oak wood used in this castle, even if there was a bad maintenance of this castle, because they use high quality material in the past, the castle can resist the properties. But okay, even if the castle was made of oak, there was some, how to call it, structural mistakes. I mean, on some of the, on let's say quite many places, they use wood of low quality. I mean, we call this kind of crack as a crack through the grain. So this crack indicates that quality of the beam used in this application was not really okay. That it has that the grain orientation on this beam was not in line with, let's say, today's standards. I mean, the owner should be aware of that, and that's why this kind of cracks appear. I mean, this indicated, I mean, because of this crack, this beam does not have any kind of, let's say, load-bearing capacities. But it was not only a mistake. We noticed quite many of them on quite several occasions. There's a second, the same type of crack formed. I mean, this crack is it's not a result of the huge load. It's not a result of a lot of snow or anything like that. But it indicates that they did not pay sufficient attention to select high quality material in terms of the growth condition. And there were, let's say, we noticed, let's say, like, I think 8 or 10 beams like that on the caster. That's far above average. It would not be acceptable on today's construction to have this kind of material.
Отже, йдеться також, thank you very much for pause, йдеться про те, що це також ось ці приклади, так, руйнування дерева свідчать про те, що використовувалося не дуже високої якості дерево. А це дуже важливо використовувати високу якість дерева. Чим вища якість дерева, тим краще воно зберігається. Дякую, thank you.
Yeah, you can see that in the past they tried to already solve this problem. You can see those screws oriented here, where they tried to fix this error in the past already. I mean, that's an old repair. We don't know exactly when they tried to do it, but it's obvious that they tried to solve this problem. In addition to that, we noticed also some insect damages. I mean, but before I move to the insects, I would like to show you those white stains. You see those white stains everywhere on this beam. Those white stains, sometimes people thought about those white stains that indicates the presence of wood decay fungi. But if you touch this material with your finger and you try to let's say squeeze it between the fingers, you will notice that this is very, very fine sand. These white powders are white crystals that are kind of deposits of a clear indication that there was a water leakage present here in the past, and the water evaporates, but those minerals that were dissolved in this water remained on the surface, and those minerals usually originate from the roofing material. So if you see this kind of damages, and if you don't see the hyphae, that's indication that there was a huge water leakage in the past.
Отже, йдеться про ще один вид загрози, так? Це комахи. І як ви бачите, ось це біле, це теж свідчить про таке, як ми говоримо, так, сирість. Ось, що виникає в результаті недогляду, такого поганого догляду, ну і впливу ось цих комах, які руйнують дерево. Thank you.
I mean, the other things what I want to point out are those borer holes. Those borer holes belongs to the deathwatch beetle. And we notice the deathwatch beetle in spruce and oak wood. This deathwatch beetle is characteristic for the old wood, and that's how it looks like. I mean, it's called a deathwatch beetle because the male representatives of these insects are hitting with their head on the wood, and we can hear that. And in the past, because the people were superstitious, they thought about it, they hear deathwatch ticking, and they thought about the death is coming, and there was a lot of superstitions about that. But it was not a death call, it was actually love call, it was a mating call. The male was trying to invite the females to join them, and it was something completely opposite than the death.
Колеги, я не буду вже перекладати тут назви комах, бо, відверто кажучи, не знаю. Ви, може, краще розпізнаєте, ну, а я вже стану спеціалістом з комах скоро. Thank you.
Okay, in addition to that, we also see the damages of the longhorn beetles. That's very common for spruce. And for a house longhorn beetle, it's characteristic that a female can produce a lot of eggs. I mean, those females can produce, let's say, up to, let's say, 300 eggs. And the damage caused by those insects can be seen like that. And we can see, I mean, usually the surface of the beam is not deteriorated, but the sapwood below this surface could be completely degraded. It's like just a sawdust, but luckily those insects are attacking only the outer layer of the beam, so they're not reducing the mechanical properties of the material too much.
Отже, бачите, ось таким чином, ось ця комаха, ну я не знаю, що це за якийсь такий навіть павук, чи не павук, а якийсь там, я не знаю, таракан, чи що, не знаю. Ось він от таке призводить до такого пошкодження дерева. Дякую, thank you.
Yeah. Okay, in addition to that, we see a lot of decay. The decay was brown raw decay. Decay caused by the fungi was the prevalent factor of all kind of damages within this building. I mean, and we can see in this image, I will show you the most basic characteristic of the fungi that we see. This is the Coniophora. It's in the English, it's called the mining fungus. The mining fungus indicates that this fungi was found in the mines with a lot of, where the material was very humid, where there was a lot of condensating water. So this indicates that there was a lot of water present on this castle as well. The second one, okay, those are also, let's say, some indication of this Coniophora fungi. In Czechia, they call this fungus Achrastavka. That's what I know. I mean, the second one, the most annoying fungi in this castle was the fungus called Serpula lacrimans. This fungus is able to grow also through the concrete or, let's say, brick walls. So they can even cause some damage on the brick material, not only on the wood. The problem associated with this fungi is that this fungi is able to produce the water during the decay of wood. So as if this fungi infested the material, they can be self-perpetuated, like they can degrade wood on their own. I mean, and we noticed a lot of damage caused by this fungus. And the third fungus was Anthrodia fungus. That was another one that was also present. So let's say it was a clear indication that there was, because the castle was so big and those moisture condition was so diverse that there were different fungi finding their optimal ecological niche to grow within this castle. In addition to that, we noticed on all the walls in this building, a lot of walls in these buildings was covered with mold fungi, with those staining fungi that do not degrade the material, but they degrade on the surface of the material. And the question is why those, how those fungi affects the integrity of wood. So I have to mention.
Питання є, отже, власне, показували ще попередні фактори, чинники, які впливають на погіршення стану дерева, так? Оцих всіх комах, і крім того, ще інші явища. А зараз, власне, було питання, яким, can you show, please, the previous slide, the question. Please show the previous slide. Okay. Oh, yes. No, the question. Так, why? Як ось ці всі чинники і ці комахи впливають на інтегрованість дерева, так? На стан дерева, на його щільність, так, на щільність дерева. Thank you very much. І зараз показують, власне, ось ці приклади. Thank you.
So the fourth thing that we do then is to measure the moisture content of wood. We are using two different moisture content measurements. One is based on the electrical resistance, and the other one is based on the electrical capacity. This one is faster, this one is more accurate.
Це вимірювання, власне, вологості деревини, змісту, і пропонується два способи. Є дві можливості вимірювання. Один спосіб є швидший, а інший є більш, мається на увазі, чіткіший, правильний, точний, більш точний. Так, thank you.
And those measurements indicate, I mean, we have measured 150 moisture content on 150 locations. That's the limit, 25%. And roughly, I would say, 30% of all measurements was above the limit.
Professor Humar, I just understood that lecture in Slovenian would be even more useful because I read влажность леса. We understand it, вологість лісу. It's more close to Ukrainian. Отже, ви бачите ось цю, боже, як же ж вона називається, цей графік, так? І оце вимірювання вологості лісу, але ви читаєте, там словенською дуже зрозуміло написано. Thank you.
Some of the words in Ukrainian, like zamak, that's, I mean, very close to Serbian as well. I mean, it's.
Yes, you are right.
Because I know what you're talking, for me, it's very interesting to hear.
It's dangerous. It's dangerous if you understand what I'm talking about. Okay, thank you.
I mean, the reasons for high moisture content can be seen here. For example, you can see a water dripping here. The roof was leaking. I mean, they repaired the building, but there was a lot of mistakes, still a lot of mistakes on the caster. You can see that this part is completely wet. That's not okay, and it's obvious it's not okay. The second type of the measurement that we run on this material is, we try to assess the density of the wood. It's very easy to assess the density of the wood in the laboratory, but to assess the density of the wood of the beam, it's very challenging. But there is a method, it's called screw withdrawal device. So we are running the screw in wood, that's a screw over here, and then we try to pull it out. And the force needed to pull out the screw correlates well with the density. And those are the results of the density. Those are the results of those SM. That's spruce, and that's oak. But we can see that, I mean, the average, I mean, the material that is below this curve, that's degraded material. But the oak was rather well preserved, and the majority of the oak was above the average curve. So, I mean, the density indicated the material was rather well preserved. In addition to that, we're also running the time of flight measurement. So we are measuring the time that it's needed for the sound to pass between those two electrodes. And if we're measuring this time, and if we are measuring if you know the density, we can calculate the modulus of elasticity based on these data. We have to be aware that those information is about the modulus of elasticity of the surface, not of the central part. But still, we at least have the impression what is the basic modulus of elasticity. This is the lower 80% of the modulus of elasticity for spruce. That's the red curve. So we can see that quite many beams were very, very degraded because of the decay or fungal infestation. And they need to be reinforced. And the second most important device that we are using resistant measurements.
I'm sorry. So, попереднє, це були різні вимірювання, бачите, вимірювання густоти. Наскільки це такі точні і різноманітні методи, які використовуються для дослідження якості дерева. І от зараз ви читаєте навіть словенською, там зрозуміло, густота, а зараз резистність, тобто опірність, наскільки є опірність. Там є такі деякі фізичні характеристики, то вже перепрошую, самі дивіться на ці графіки, на ці лінії, але що можу, то перекладаю. Дякую.
So using this device, we are measuring we are measuring the resistance, the momentum of the needle penetrating the wood. So the needle is penetrating this direction. These are the growth rings. We can see the difference between the late wood and early wood. And we can still see that in this case here, this part is degraded. So we can see what happened with the cross-section of the wood. And we have analyzed the 500 beams on these castles. I mean, and because we want to indicate that something is wrong, let's say immediately, we mark those beams immediately. We mark the beams that needs to be replaced immediately to help the owners where they need to replace it. Like this. This part is completely degraded. And this is the example of the curves. That's example of the perfect curve, 90 centimeter wide beam, no decay. This one is a bad one. Decay here, decay, decay, decay. That's example of the bad beam. This one is the worst beam. There's only a bit of material here and nothing here. This one is almost completely degraded.
One moment. Отже, ось ці графіки показують, наскільки в поганому стані дерево і розпад цього дерева. Ось цей графік, ви бачите, все стає менше, менше, менше. Оцей найгірший варіант. Якщо ось така ситуація, то практично не відновлюється. Thank you.
Yeah. So, I mean, and then we calculated the degraded cross-section. So as I mentioned, we measured 500 beams. On average, 14% of the whole cross-section were degraded. The median value was 4. So 90 beams has more than 20% of the degraded cross-section, 72 of the 30, and 50% of the 39. We decided that they have to replace those, have to be replaced. And this can be reinforced.
Ось це має взагалі бути замінено. Ось це нижня, бачите, позиція, і там відразу видно середнє значення, потім більше, ніж 20% деградації, 30, більше, ніж 30 і ніж 50. Коли є більше, ніж 50% деградації, ось та лінія, бачите, термометр замірює, то мусить бути замінено. Вже все, не підлягає відновленню.
I mean, one of the basic tools that we are using, it's very simple. It's the same, I always have it with me, it's knife. That's the basic tool that we're using. I'm using the same knife. So my colleagues are joking that I should use the one with the red handle, because then you can see it better on the photos. But you can easily see also if the degraded part with a knife. There's so, I mean, sometimes knife is enough. Or like in this one. And you can see very degraded part.
Отже, з допомогою ножа можна дослідити, наскільки дерево втрачене, чи потребує, чи піддане розпаду, чи ні. Бачите? Так. Okay.
And what were the recommendations? Some of those recommendations are very obvious. Building needs to be dry. Wood needs to be dry. Because, I mean, they have to work serious and they have to dry the material. Fully degraded material have to be replaced. All new material that is inserted in the building have to be impregnated with copper-based preservatives. And all walls where there was any kind of indication of the fungal myceliums have to be treated with open flame. In addition to that, we also recommend them to install those moisture not necessarily this one, but a similar moisture logging device. I mean, that's a moisture logging device. We're using those moisture logging device. And those moisture logging devices are sending the moisture content twice per day in temperature into the cloud. You can see it here. We have all the data, what's happening on the building, on this information. So for the if they spend millions for the renovation of this castle, they can easily afford this kind of sensors to monitor the building.
Отже, там були показані рекомендації, що треба було робити, чи висушувати дерево. Попередній ще слайд був одне висушування дерева, там більше, там ще щось за допомогою гвинта. Але ось цей пристрій, він, власне, пан професор малює пристрій, і ви можете бачити, що цей пристрій дозволяє, власне, і вимірювати дуже багато показників, пов'язані із якістю деревини. Thank you.
In addition to that, we recommend them to treat all the wood in the building with copper-based wood preservatives. They can use this kind of spraying because in the house, in this kind of castle, it's very difficult to use because 80% of the wood beams were at least partly degraded. So we recommend them to use this kind of spraying device to treat the material with copper-based wood preservatives. We usually suggest that copper base because copper acts like a fungicide, boron acts like insecticide, and quaternary ammonium compound works against the molding fungi. And this will prevent further degradation of the construction. In addition to that, because for some parts were really, really degraded. In this case, we recommend them to use those fungicides. It's called Dazomet. This is the preservative that is approved in it's a legal chemical, and they use it very frequently in Germany, predominantly for treatment of the poles. If there's incipient decay present in the pole, you put it like that. It's a dusty material into the wood, and in wood this material is slowly decomposing, and when it's decomposing, it's reacting with wood and stopping the growth of the fungi. On those images we can see the experiment with a pole without Dazomet, this fungicide. In this case here we see the poles with Dazomet. In this case we can clearly see that this Dazomet prevented the growth of the fungi. This Dazomet is also very frequently used in agriculture for production of the strawberries in the greenhouses. It's very common chemical. Of course, you have to be careful when you're dealing with chemical, but in these castles where we cannot replace the wood, it's one of the options how to use it.
I would like to explain, я б хотіла пояснити, що бачите, оці рекомендації, оці елементи, які замінити ніяк не можна. І ось цей малюночок, він показує стан деревини, коли замінили цей Dazomet, а ось стан деревини, коли його не заміняли. І, звісно, він набагато кращий.
In addition to that, we are interested in what are the mechanical properties of the old wood? In this case, we run another experiment. That's a different sorry, that's the one in Jesenice, but I just want to show you, for example, because we did this experiment on this building. It's also 400 years old material, and it was also degraded by the fungi, but we were able to isolate some of the wood material for analysis. That was a large wood, Larix decidua material. You can see it's the sapwood, that's the border between the sapwood and the hardwood. This one is degraded, but the hardwood remains rather okay after 400 years. And that's how it looks like under the microscope. And when we compare the old, that's a new material that we get from the forest, and that's old wood. Old material have much, much higher density than the new wood because probably the growth condition was better at that time. It has a better static mechanical properties like flexural strength, and it has a better bending strength. But we were also interested in what are the dynamic properties of this material. For this purpose, we applied, I'm not sure if this one will work. We applied, can you see it? We applied these fatigue tests on this material. So we expose wood specimens to cyclic loadings. And we counted the number of the cycles that this material survives before it breaks. And those are the results. That's the number of the cycles, loading cycles, required between them when the material is collapsed. So if material was exposed to the 75% of the maximum loading, maximum bending strength, it can survive 1 million cycles. If it is exposed to 80%, it survived 400,000. If it's exposed to the 85%, let's say 100,000. That's for the fresh material. New material, you can see the data. Let's see the scale. In this case, the upper limit is 2.5 million. In this case, it's 300,000. Old material is much more tired, and it can survive less cyclic bending properties. But if the material, I mean, even if we see the type of the cracks, you can see that that's a type of the crack of the old material, and that's type of the crack for the fresh material. We can see that this one has shorter fibers, that the fatigue is different. It was the same insect that also caused the damage in this kind of construction. And if there were a boreholes present in the material was very, very sensitive to the fatigue. It cannot survive any kind of the fatigue force. So what we want to know that in this case, so in this, if we have old wood, we have to be more careful when we're exposing the old wood, let's say, to the cyclic loads, like dense floors. Dense floors is a typical cyclic load. But if it's only static load, it's not a problem. And I mean, this brings me to the end. And I would like to thank all our financiers that helped me to run this research. And I would like to thank you to having me here. And I'm really happy to answer all of your questions.
Okay. Thank you very much, Professor Humar, for very interesting aspect of cultural heritage protection. And I understand now that I need, or we should think about not only integration course on cultural heritage in war, damage, conflict, but also chemistry for cultural heritage, because it's really interesting. This point of view. So I would like to ask our participants. So thank you so much for delivering this interesting lecture. And I address to participants, if you have some questions, please, floor yours. Шановні колеги, ми дуже дякуємо професору Гумару за такий дуже цікавий аспект справді захисту культурної спадщини і аспект розгляду деревини, так, аналізу, моніторингу стану деревини і, власне, що можна зробити, щоб покращити цей стан. Ось тут, бачите, матеріали, які, втрата цілого, так, порушення цілого, і яким чином можна цьому запобігти. Отже, я вже дала таку пропозицію, що нам потрібно думати не тільки про курс втрати культурної спадщини в час війни, але також і ввести курс хімії або курси, от, власне, таких розрахункових якихось технік і досліджень, бо ці знання потрібні навіть для перекладу. Будь ласка, колеги, вам слово і вам запитання. Будьте активні, прошу дуже. Хто має питання?
I mean, the problem of the infrastructure, all this kind of buildings, if they're damaged during the war, is this water leakage. And I mean, the longer it takes, the more problem appears on the material.
Yeah. Шановні колеги, чи маємо ми запитання? Будь ласка, будьте активні.
I don't have a question. However, I would like also to say thank you for this. Probably when I firstly have read the name of this lecture, I was a little bit not I'm not shocked, but what's it? How, in which way, how it can be connected with the topic of cultural heritage management? But now, after these lectures, I understood that it's maybe not too close to, but for our students, generally for staff of cultural heritage management, it's important. Just probably such similar, like simple case, understand in which way how it can be used. For example, when we are preparing some, I don't know, applications connecting with management on castles, so on, or generally another cases, we should know in which way how it can be used and what should we do. Of course, not we, but probably another specialist, but we need now how it should be organized. So it's important in such case. So thank you.
And
Welcome.
I have a question also, Professor Humar, concerning your specialty for your students. Yes, so what specialists are they? I mean, from the Department of Wood Pests, Wood Modification, Protection, and the Faculty of Biotechnology. So what specialization these students have?
I am teaching on 3 different subjects, 3 different programs. One of them are wood science students. I mean, if you're thinking about the problems of decay in old building and new building, it's the same. I mean, if you have problems in the building, it's like, I always said, like, the first sentence is Anna Karenina, all happy families are, all happy families are the same, but all sad families are looks like us, sad on their own ways. If you have a problem on your house with a decay, you are like a sad family and you have a problem. So, our students in the wood science studies try to understand how to prevent this kind of damage. And if this kind of damage appears, they have to know how to solve it, especially on new buildings. But if we are talking about, let's say, then the second students that we have are biotechnology students. We are learning biotechnology students how to use fungi for their own good, how to use the fungi to use them as industrial organisms. And the third group of students are conservator students, the students that are working on the conservation of the arts. And we are trying to get them familiar how to prevent the decay of cultural heritage, how to stop it, and how to remediate those kind of treatments. So those students we have in those courses we have.
Great. Thank you very much. It's very interesting. Thank you so much. And I hope that we will meet together someday in the future. Yes, thank you.